Alright, we're going to pick up where we left off. We covered through page 29 or 30 or so last time. So we're going to pick up there. I added a few things over the weekend. I actually went in and recreated the recordings for chapter 1. And I also made a separate recording here about how to use Python in a separate file, what you need to do for the assignment. Okay. The reason you need to do yours in a separate file is that way I can see it. Okay. I also put a helpful info link, which we'll see here in a few minutes. But I try to add stuff here all the time for you guys. You all saw my note in the course homepage about the tech support I got about my crashed video. They basically said, sorry, can't do a darn thing for you. So, but I did get it fixed. Well, I created a new one. And the new one was a lot shorter. It was only 35 minutes long. So I must have said something in class I didn't record, or who knows what. But alright, we left off on page 30. Okay? So I'm going to go back here. Go to page 30. Come on. Come on. 28, 29. This should be 30 right here, isn't it? That's 29. Well, we left off talking about defining functions. We're actually going to be doing that today. Okay? And on page 30, they actually have a function called draw square, which we're going to do. I'm going to actually walk through this entire thing. Okay? Now, I need to bring up Python again. Now, last time in class, I talked about how you can do it in different editors. The easiest way, in my opinion, just go File New right here inside of the Python shell. And that's the editor that comes with it. It works on every language. It works on Mac and every other darn thing. So, I wonder if I can make this smaller so I can see it all on the screen. Let's see here. I got my resolution kind of big so y'all can see it, but it kind of makes life difficult for me. Okay, so what they're doing is here, they are defining a method called draw square. Okay, everybody see that? Hopefully you see that. Okay, I'm going to type this in to the editor here in Python. DEF stands for define, and I'm going to call it draw, just like they're doing. Draw square, needs a parentheses. Then we have my turtle side length. Okay, let's talk about that for a second. They do talk about this in the book. First of all, the DEF, like I said, is define. We're defining something for the compiler. Draw square is the name we're giving it. We can call it anything we want. I mean, if you want to follow along, that'd be great to make sure yours works. So draw square can be called anything we want, but we don't want to use the reserved words. Then we have two items inside of parentheses. They're called objects or arguments or parameters. It really depends on which language you're referring to. But in Python, they call them objects. What this means is this new method called draw square will receive two objects as arguments. It will receive a turtle and a length. Okay? And when we call this, you see how it actually all works together. Okay? Then you need a colon at the end. So that top line is really the method header, or the method declaration, you can call it. Then when you hit enter, it should automatically indent by 4, and then you can type in the rest of your stuff, like my turtle dot forward, and then side, oops, spell it right, side length. Now my turtle is the first object that it's receiving. Everybody see the two objects, my turtle and side length? They're in a specific order, and it matters. So when we call this method, they have to be done in the same order. So what we're doing here is we're taking the my turtle object, we're telling it to go forward a specific distance, and the distance is how long we specify in side length. Okay, then I'm going to say my turtle dot right 90. Whoops, 90. Okay. Now on the book you'll see they have a pound sign side 1. Okay. Anybody know what that is? That pound side one? Someone's got to know. A comment. Very good. Comments are very important. Okay, let me tell you a story. Way back when I first started doing this, there was an article in a magazine. This company hired a programmer to write software for them. He worked for them for an entire year. At the end of the year, he quit. Well, he didn't document his code whatsoever. It's kind of like he built them a house without a blueprint or without making notes. They went back and sued him and proved in court that every single piece of software he wrote was now considered worthless. And they won. So every penny they paid him, he had to pay them back. So they proved his entire time period of working there was produced no results. Think about this. If you ever build something at your house, yeah, while you're building it, it's fresh in your brain, you know what's going on. But what happens when you come back a year or two later? A prime example is I had my house built, okay? Before the walls were put up and they were just the studs, I put in all the network wiring. I put in 27 drops. Each drop had a Cat 6 for network, a Cat 5 for telephones, had a RG6 for cable. They were all inside conduits. I had speaker wires installed in all the ceilings. So I did all that myself. And I took pictures of everything. So that later on, if I wanted to activate the speakers in a specific room, I could look at the picture and knew exactly where the wires were hanging down, just got a little hole and pull them down. I lost all the pictures, believe it or not. I was very upset because now it's like I know there's speakers in every room, but where? And my attic has so much insulation that it's not easy to find. So now it's kind of like poke a hole and hope it's there. But really my pictures were my documentation because I knew how I did the job. Well, this here isn't that hard to figure out. But as you write programs, see, there's what's called the maintenance phase. I think we mentioned it already. If we didn't, I'll mention now. But writing software is a very small part of the job. 75% of the job is maintaining the software. Think about it. They produce Windows 7 or Windows 8. How often do they make updates? Isn't it weekly? Pretty much. Seems like daily sometimes. They spend 75% more time maintaining the software than they did writing it. And without comments, without documentation, you don't have a clue what you did. Especially when Kyle Cook used to work here. Kyle Cook worked at Air Inc. as a part-time job. That's right off of the Air Depot on 59th Street gate off of Tinker. Well, when he left there, Frank Woodall, who used to work here as well, took over for him. And it was kind of funny because there was this one piece of code that Frank found that Kyle wrote that he had no earthly idea what it did. It's literally, he looked at it for days, couldn't figure out what he did. So he asked Kyle, he goes, everything's well documented, everything's right except for this one piece of code. What does it do? Kyle's answer was, we had a contest to work. Who could make the most obscure piece of code that no one in the world could ever figure out? And he did, because Frank literally had no earthly idea. But Kyle told him how it actually worked. The point is you need to document stuff, okay? So again, side one, not so much. But when you write stuff in the real world, it's always nice to know how things work, okay? Now, I need to do this 4 times. So I'm going to get down here and copy it 4 times, okay? Why type it 4 times? How many of you actually typed all that 4 times? No one's going to admit it. Okay, now we're going to go over here. We're going to put a 4. So anything after the pound sign is considered a comment. Okay? So I got my method all made. Now I need to save this thing. I'm going to save my file. Now I'm going to save it in my desktop in a folder called script programming. And I'm going to call it ds.py for drawsquare.python. Okay? I'm saving it in my desktop. You guys can save wherever you feel like, but I always put it there. It's easy to find. Okay? Now it's done. Okay. So far so good? Everybody with me? Now, they continue on, and now they get to the point where they want to use it. Okay, so I got that file still up, but I'm going to bring back up the Python interpreter. And I think last time I might have called it a compiler. It's not really a compiler. It's an interpreter, because Python's not really compiling the code. It's actually just running it. Okay. Now, from inside here, just like we import Turtle, we want to import the functionality of that file we just made. So I'm going to go from ds import asterisk. What that means is, from the module called ds, which I just named, ds.py, you don't specify the py, from ds, import everything. Okay? Anybody get that problem? Does anyone have a clue why I got that error? This is no such module. I swear I called it that, didn't I? Let's look. Yeah, it's called ds.py. See right there at the top? Those of you in the expensive seats can see that. So I called it that. So if I called it ds, then why isn't it working? Anyone know why? What? Not where?
Not py.
Well, no, not really. No, because you don't specify the py.
It's looking in the wrong folder.
It's looking in the wrong folder. Okay? The reason is Python runs from a specific folder, which is under the C drive, under the Python 3.4 directory. Which, let me show you where that is. Okay. Runs under C drive in a Python 3.4 directory, and it runs in here, and then you can put your includes here, you can put your scripts in here. So if I was to move it over here, I wouldn't get that error. But that's not a good solution for me. Okay? Because can you imagine me taking each one of you and having to put your file into my in my Python directory? It's just going to cause an issue. Okay? And sometimes you don't have permissions to write to those directories. So how do we fix this? There's got to be a way to change the path. Well, up in our class page, under a folder or a module called Helpful Info, I added something. I added a page called Helpful Info. I'm telling you how to change the working directory in idle. Okay? Alright. First thing we know to do is we've got to import OS. So I'm going to go back into here. I'm going to say import OS. What that's doing is bringing in the functionality of the operating system so I can do stuff. Okay? Now if I want to see which directory Python's currently looking in, I can do that next line. os.getCwd. That stands for os.get current working directory. So, Python is looking in my C drive in the Python 3.4 directory. That's the only place it's looking, which is not handy, because that's not where the file is. So what I can do is I can change it. So I'm going to do os.chdr, okay, and I'm going to put in the directory. Now I can go C:, we haven't talked about escape characters yet, but you need to use double slashes. I'll explain that more when we get to the escape characters. But the reason is, one slash is an escape character. It says, hey, I'm doing something special. But we really want a slash, so that's why we put two of them. So it says, yeah, it's really something special, but it's really just a slash. Then I want to go down to, now I got to find my what you call it there? Desktop. It's on my, wait, no, it's not. Is it documents and settings? No, it's users. Oh, come on. Users. Come on. Users. K. I hate when it doesn't stay on there. KDewey. Desktop. That should be where it's at. Then script programming, I think. Let's see. Am I right? Yep, script. Why doesn't it keep that? I know you can bring it up. No, it's not spacebar. No, it's not enter key. I can never remember what the darn thing is to bring that up. Script programming. Okay. So that's what I did right there. That should match my directory. And you can also, if you bring up the folder where it's at, you can literally just click in here and copy that out. And then just put an extra slash. What I did was I brought up the folder where it's at. If you click up here on the little bar, you can copy and paste it. Then just add an extra slash. It's the same thing. Okay? Alright. So now I'm going to go up here and hit enter. So what I did is I told Python, hey, go to this directory and make that the current working directory. So now I'm going to go back to this command up here, this from ds import. Now if I hit enter, it should work this time. Yes, it worked. See that? I no longer got that error because I told it, hey, when you're looking for something, go over here and look for it. Okay, so let's bring the code back up, bring this back up. All right, so now we got the first line in there. Is anyone totally lost? I'm not going to get a minute. Okay. So now I'm going to import turtle. Why didn't I have to specify where turtle was at? Well, because that ships with Python. It always looks in itself first. Okay, it's something like name resolution, but you know, it's all right. So import turtle. Now I'm going to say t equals turtle dot turtle. Hopefully everybody knows exactly what that means. We talked about that last time. Oops, don't put a slash at the end, not good. Then I'm going to say draw, and by doing that t equals new turtle, I should get this window now. Okay. So now let's go back to the window. I want to draw, what size? Draw t, draw a square, t, comma 150. What that's saying is, draw a square, which is that module we just imported, the one we wrote. Saying draw a square, and we're passing in two objects. We're passing a t. Now what's t? It's the new turtle. It's the new instance of the turtle object. Then what's 150? It's just a number. We're passing it the number, and that number is going to end up being our side length. See that when we made that thing? Okay. So now when I do that and hit enter, I have a square. We just drew a square. Okay. Now if I move this over a little, I want to draw another square. So I'm going to bring this back up, but this time I'm going to say 250. Okay. Should I be able to do that? There it is. So now I have two squares. You know, it's kind of hard to see. It's right there. So how can I use this code I already wrote, but draw a square to the top left instead of bottom right? Anybody? Can I do it without changing my code at all? Let's look at our code. Our code receives an object for turtle and an object for side length. And we're going forward a length, then we're taking a right-hand turn, and so on and so forth. Do I need to do left-hand turn? But what if I don't want to modify this at all? Anybody? What if I go back in here? I'm going to bring this line back down because I want to. What if I say negative 150? Oh, look! Now I bring this line back down. And my negative 250. Look at that. Now I got my baseball diamonds. Okay. Kind of handy. So we wrote one method called draw square that we just used 4 times. Kind of cool, isn't it? Okay. I guess I could, I could specify different sizes in here. I could say, let's put this one at 75. And now we should have a smaller box inside of there. So you can make it do all kinds of different things. All right, so far so good. Everybody with me? No one's totally lost yet? Okay. That was page 30. So now I need to open up the next file. Okay. I need the next page. All right. Page 31. Okay. They're basically saying what we just did. One thing I didn't do, okay, if I just go in here and I write draw a square all by cell, I get that. Does anyone know what that is? It's the memory address of draw a square. Remember, we wrote that method called DS, then we imported it in. When we imported it in, we had to import it somewhere. We imported it in the memory. So that's the actual memory address on this machine. Now, I'm assuming this is a 32-bit machine up here, because when I do this downstairs, I get a lot bigger memory space than this one. So I'm not positive, but okay, either way. All right. So, everybody kind of understand how that works so far? Yes, no? No one's totally lost? This is not... Yes, ma'am. Okay, let me come look real quick. Okay, my turtle... Okay, you did that, you did that. Okay, let me see draw square. Where's your other file? Let me pause my recording for a second. Let me pause this recording so we don't lose it. Okay, so now we should be recording again. Yeah, okay. So most of us got this working, those of us who did it. So now we should have our two squares. And I think I pretty much explained that. Now, could I have another turtle? Sure, let's make an S turtle. Turtle. Let's spell them right. It's weird how little spelling errors gives us big issues. Draw square. Darn it. And now we're going to do S. And let's go negative 50. So what that should do is we should now have a new one. We have a little teeny tiny square right there. It's really on top of the turtles are both there. Like, yeah, it's hard to see. So, okay, so you can have multiple. Now we actually have two different objects. If I was to type T, that'll show me where in memory my T turtle is. If I type S, you'll see it's different. Because I actually have two different objects right now in memory running. Okay, I can make as many as I want. Okay, let's continue on. All right, so we pretty much talked about all that. What they're talking about here is the namespace, how it's a little different, and how, when we created the T turtle and the S turtle, it creates a new object in memory. Now, when we call them, you'll notice how right here we said turtle.turtle. Means of type turtle, we want to create a new turtle. So then why couldn't I say T.drawSquare? Does anybody know? If you know anything about programming, if you had any other programming classes before, a lot of times you say T.drawSquare or S.drawSquare. Does anyone know why I can't do that? Well, let me explain why you can't. First of all, turtle is not something we created. You agree somebody else made it? So, in order to be able to call T.drawSquare, I would actually have to be editing the module that somebody else made for turtle, which we didn't do. So what we did is we made our own called drawSquare, which receives the turtle as an argument and just manipulates it. So, if you're wondering why I'm not saying T.drawSquare or S.drawSquare, it's because I would have to edit the turtle module and then re-import that, which we could do. If you ever see, like, you know how Java gets updates every 5 minutes? Because they're finding problems in it, and they're always updating it and fixing it. And the way they fix it is by giving you, I mean, they might only be changing one little bit, but they got to get you a new version. That's how they keep track of them. So you get the entire Java language reinstalled if they only fix one little line of code. What sucks is the other, I don't know if you know this about Java, it doesn't remove the old versions. Yeah, if you ever go out and like program files on your computer, you'll probably see a whole pile of different Java versions in there. I think that sucks, but that's the way it works. Okay, let's continue on. All right. Okay, now let's talk about repetition. Okay, over here, we wrote this method. You all agree with that? We wrote that. Well, I wrote it. Hopefully, some of you wrote that. I wrote the same thing 4 times. Was that good or bad? I mean, it's okay, but why? Why am I doing that? Why did I just write it 1 time instead of to do it 4 times? Okay? Cameron works down in my office, okay? Before Cameron, Roy worked in my office. Roy was very different. Roy was one of those people that if you tell him to do something, even 1 time, he won't do it. He'll write a script to do it. Because if he ever has to do it again, he's already got the script written. So Roy was always preparing for that second time. Way back when, I used to run a network consulting company, and I had to help install a VPN router from down on North Hills Expressway to make a connection to North up in Edmond. Okay, just had to configure their VPNs for them. This is way back before all this GUI stuff. So I said, I'll do it for you. Configure the 2 routers. I'll charge you $600. Because I didn't know how long it was going to take me. So I did it. It was all command prompt. It was like 200 commands. But I got it working, but I wrote a script to do it. So that, it was a lot of trial and error. So I get it all working, charged them $600. It took me like 2 days. So they're like, man, I think we paid you too much. I'm like, but I did it. That was the agreed upon price. They're like, we think we paid you too much. We're going to do the second. They needed another one done between there and Dallas. We're going to do the second ones ourselves. I said, that is fine. Go for it. So a week or so, maybe 2 weeks later, they call me like, we can't get it to work. They says, will you do it for us? I says, $600. And they're like, seriously? I'm like, that was the price we agreed on at the beginning. So, me being the smart guy, I kept my script. So I literally logged into the router, changed the name from Edmond to Dallas, hit enter. $600, please. And they're like, seriously? I was literally done in 15 minutes. But the point is, why recreate the world? Why type this 4 times when I can type it 1 time? Understand? Okay? So you'll learn that a lot in programming. It's one of those things like, there's normally an easier way to do everything. Okay? So we're going to modify our draw square to use a loop. We're going to use a for loop. There's a lot of different types of loops. There's a while loop, a do loop, and a for loop. For loop's my most favorite. It's, just what we're using, okay? And the way the for loop works is for I in range n, then a bunch of statements. What that means is for I, that's some variable we're going to create, in a range, in other words, until something, some number, do something, do some statement, okay? And here they show you, this says, for I in range 10, that means it's going to do something 10 times. Easy enough. So if we want to do that draw square thing 4 times, we could just do for I in range 4. Okay? So now we're going to edit our draw square module. Okay? So we're going to bring it up. Let's bring it up to the top here, if I can get my mouse. There it is. Okay, so I'm going to draw square. Really, I really only need the first one. Okay? So I'm going to edit this thing. And I'm going to say for I in range 4. Okay? So far so good? Then what happens is it's going to start at 0 and continue less than 4. Okay? Now, I need to indent this as well, because the way this functions is it always goes by the code that's indented underneath it. Okay, so this is telling us whenever we call draw square, I always automatically starts at 0 unless you specify something different, which we haven't learned yet. So from 0 until less than 4. That's just the way it is. It just makes it easier for us. So do something 1 to 4 times. Okay, so far so good. Now I'm going to save this. Save. I'm going to go back here, and I'm going to close out my turtle. Actually, I'm going to create a new turtle. I'm going to create a new turtle. This one's going to be called P. There you go. We got a new turtle called P. A friend of mine went and saw Ninja Turtles. Said, "Wow, what a waste of money." Anyone else seen it? He was like, "Man, was it not worth it?" Was it?
Second most money-making movie I had out.
Was it? I mean, I haven't seen it.
It's not good. It's a Megan Fox show, and it's horrible.
Oh wow. He also saw the Galaxy one.
Yeah.
No, that's one I want to see.
The Galaxy.
He said he saw it twice. He loved it. I'm like, wow. I haven't seen that one yet. All right, so we got our turtle going here, our P turtle up here. Okay. Now we got that. We need to go back in here. Now we're going to say draw a square, if I can spell correctly. We're going to pass it P this time. Let's just do 150. So if it works correctly, it should do the same exact thing. Don't you agree? And where's my turtle? There he is. So it worked perfectly, and now I wrote less code. Instead of, we had before we had 8 lines of code, and I brought it down to 3. So are we more efficient now? I taught actually in our computer encryption class, have them write a Caesar cipher program to decrypt some letters. And I wanted to see it. What's the shortest number of lines it could be done in? I got it down to 3 lines of code in Java. And I was like, there's got to be a way to make it better, make it faster, that. So, everybody understand how repetition works so far? We're going to talk a whole bunch more about this for loop. But now our code is much more efficient. Is there anything wrong with the way we had it?
It's a lot more work.
Right, a lot more work, and it actually takes up more memory. Because this code is actually stored somewhere, and it takes up more memory. And the one for my encryption class, I give them, I think it's 384 character paragraph they have to decrypt. And I give them an example where I do the first 5 of them. I do them manually. I decrypt the first character, then the second character, then the third, fourth, and fifth. Somebody emails me this week, and they're like, do I really need to copy that code 380 times? Mike, I hope not. But I didn't want to give them, I don't want to do it all for them. I was just showing how it's done. Hopefully they go and figure out, man, this sucks writing it 384 times. I can make it better, like something like this. Okay. See, the cool thing is Cameron's going to get down to the office. He's going to redo his assignment in Python now. There you go. All right. All right, so let's talk a little bit more about this for loop. Okay. So we said for I in range 4. Okay? So it starts at 0 and goes to the stop -1. The way range works, it talks about it right here. Okay? Range, you can specify one thing. In other words, where to stop at. So when we did I to 4, range 4, that says stop at, or start at 0, and stop at the stop number, which was 4, -1. See that right there? It says create a sequence of numbers starting at 0 and going to the stop number -1. So starting at 0 and going to 3. 0, 1, 2, 3. We did it 4 times. Or I could specify the start and the stop. I could have said range 2, 3, and what would it do? If I did 2, 3, how many times would it run? 1 time. because it starts at 2 and goes to 3 minus 1, which is 2. Okay? Or I could do start, stop, and step. I could say start at 5, stop at 100, step 5. So it goes 5, 10, 15, 20, 25. So you can specify any way you want. It's kind of cool. It's one of those, what's the word for it? It's like overloading. Some of you might have heard of that before. We are making the method, there's a range method built into our loop that takes either 1 argument, 2 arguments, 3 arguments, or so on. Okay, so far so good? All right. And here's an example of 0, 60, and 5. Starts at 0, goes to 5, 10, 15, 20. Why did it stop at 55? What?
Because it started at 0.
Started at 0, and it goes to stop minus 1. Stops at 59. So it hit 55, printed it. It increments to 60, up 60 is greater than 59, quits. That's how it works. It's really called the control. In Java, it's called the control value. Here it's called the stop value. Okay? In Java, it's called initialization, control, and update. This is start, stop, and step. I mean, it's the same thing. So that's what's cool. If you know one language, they're all the same. It's just changed a little bit. Okay. So far, so good. All right. So here we have an example where he's modifying it for side length n. And actually, let's do this one. Well, this is a spiral. We need to make a new method. Okay. So I'm going to go, let's get rid of this turtle. I'm going to create draw spiral. File new. Okay. Don't want it huge. Come on. Gotta get it small here. So I'm going to create a new one called DEF draw spiral. SP spiral. My turtle, and I need to pass it the max side this time. Okay, let's go with max side. Okay, now I'm going to do for side length in range. I'll talk about each one of these. Max side plus 1, comma 5. My turtle dot forward. Forward. Man, I can't type. Side length. My turtle dot right. All right. Let's talk about what this thing does. Okay, let me make this a little wider so we can see it all. Well, still can't see it all. Nope, it's supposed to be 1. All right. So we defined a new method called draw spiral. It's going to receive 2 objects or arguments. One's the turtle again, and one's the maximum side. Okay. So I spelt length wrong, didn't I? Yes, I did. That would definitely cause an issue. So for side length, last time we had 4i. So really that variable can be called anything. For side length, in range, 1 max side plus 1, 5. So the start is 1. The max side plus 1, so in other words, the stop is whatever number I specify. And then we're going to increment by 5. Okay? Then we want it to go forward the side length and then take a right. So far, so good. I'm going to save this one as DS. File save. I'm going to put it in the same directory and call it, well, we already have DS. What they call theirs? Come on. What'd you save it as? I'm trying to make it the same. They didn't tell me what they, I think they overwrote their other one. Draw spiral. Alright, I'm going to call it DS2. What? DP?
No, never mind.
Yeah, I thought I saw where they named it. Okay, file save. I'm going to call it DS2. or DSP for draw spiral. There you go. DSP.py. Okay? Now, I'm going to go back in here. Now I need to bring in the functionality of DSP. So, from DSP, import asterisk, and hopefully we get no errors. Yes. Okay. Let's make a new turtle. We want a Q turtle. Q equals turtle dot turtle. Okay, we got our turtle. Now let's, come on. I need to go here. Q, no, draw spiral. Q dot, or Q, let's say 150. Let's see what it does. Look at that.
Oh, wow.
Isn't that cool? So what the heck did it just do? Well, I passed it the name of my turtle, which was Q, and I passed it at 150. So it received Q into my turtle. It received 150 into max side. So far, so good? Okay. So it said for side length. Side length is a new variable. So we're creating a new variable right now. In range 1. So side length is set to 1 initially. And the stop value is max side plus 1. So it's 1 and 151. So the start is 1, the stop is 151, and the step is 5. Okay? So we're saying my turtle dot forward side length, which is initially 1. So we started at 1. So it moves forward 1. That's that little teeny tiny thing going sideways right there. Okay? After it went forward 1, it took a right. Now since this is a for loop, we came right back up to the loop, and now we increment by 5. So side length went from 1 to what? 6. So then we move forward 6. So this next line going up and down right there should be 6. Then we take a 90 again. So now we're heading that way. We go back up, we do our step. So 6 plus 5 is 11. So now I come down here, move forward 11. So this line right here should be 11. Take a 90. Now we're facing up. 11 and 5 is 16. And we keep going until we get less than 151. Okay?
Like machine programming. I'm going to be a machinist at one time.
Right.
I took the machine programming classes and stuff. It was like this.
Yeah. It's, see, what's weird is, you look at this. We know it's going to draw a spiral because the name's draw spiral. But isn't that, the code really doesn't look like a spiral. You actually have to think. All right, I want to make him, I want to draw a bigger spiral. So what happens if I bring this line of code right now and change it to 250? What's going to happen? Start where?
From where it stopped.
Right, it's going to start from exactly where it stopped. So it's not in the middle anymore. So it's actually going to be doing it on top of the other one. We're just going to go more this time. Isn't that cool?
Well, what happened if we actually would have put it to negative?
Oh, put it in negative? Let's try that. That's a good answer. It should go up to the other side. Negative 150. Let's try it. Maybe not. Oh. Because we're less than the start value, that's really going to screw it up. Because this time we're using the step, so it's not going to work. Because remember, it gets the side length, okay? So it receives a 150, negative 150, but so we're already less than what we started with, so we're already below it, so it's not going to do anything. Understand that? So instead of telling it to stop at 150, we tell it to stop at negative 150, but we start at 1. It's like, oh, 1 is already greater than quit. So to fix that, excuse me, we would have to tell it to do the left instead of the right and that kind of stuff. So, all right, let's continue on here. All right, so there's our draw spiral. That's pretty much what we talked about. It's exactly what we talked about. Okay? All right, drawing a circle. Now, we're not going to have enough time to go through all of this, but we're going to play with it a little bit. So, let's make a new method called draw triangle. This one's kind of cool. Let me get rid of my turtle again. I'm going to make a new one, new file. Once again, shrink it down so I can see the screen. This one's going to be DEF, draw, triangle. I'm just going to call him T. Side length. Save on typing that way. All about conserving keyboard usage. I in range 3. Okay? T dot forward SL T dot right 120. Okay, is there anybody here who remembers how a circle is made? I'm not a circle. A triangle is made? How many sides are on a triangle? 3. Very good. And what's the, if you add all the angles together, they equal 360? Okay. So hence, to draw a triangle, we need to make 3 sides, so our loop goes 3 times. What values for I are we using based on this example? What are the values for I? Starts at 0, goes to 3 minus 1, so it goes to 2, so it goes 0, 1, and 2. Okay? Trust me, that's going to be on your test. So don't forget that. Okay? I'm going to save this one as DT. You got the DTs. Isn't that like some weird disease, DTs? They would, soldiers would get that or something. Or, no, not soldiers. Druggies. Druggies. I guess the soldiers could be druggies. All right, let's see if this works. All right, so we got a new one called Draw Triangle. This one's even going to be a better turtle. It's going to be called K. Okay. We have our new turtle. It's called K. Men in Black, remember K? Yeah. Okay. So now I'm going to say draw spiral. Oh, wait, we didn't even, wait, you know what? That's a good point. We're going to do this. Draw, wait, triangle. Wasn't it triangle? Press a K, and actually it's just K this time, isn't it? Oh, we need side length. Okay, let's give him a side length of, say, 100. Alright, I got an error. Does anyone know why? What? Not imported. I made the method draw a triangle. I didn't import it. From DT, import everything. Yeah, that whole asterisk. I mean, I could maybe I had a method that had a bunch of functionality to it. I could specify a specific method in there, but this to get all of it. Now I should be able to go in here, draw a triangle. Oh, isn't that pretty? Come on, you're impressed. I know you are. Okay. All right, let's continue on. If you're lost, please yell at me. Okay? Now, they modify theirs to draw a circle or polygon and all kinds of other stuff. That's actually the rest of the chapter. Okay? I'm not going to walk through each one of these. But what they did in here is they're telling you, a triangle has 3 sides, square has 4 sides. So you take the 360 divided by how many sides there are to figure out the angle. Now, so far, our guy has turned 90 degrees. Do we have to turn 90? No, we can turn 72, 45, whatever we feel like, okay? You are free to walk through all these. That's fine. I'm just not going to walk through all of them, okay? Then the cool one to get down to is now start drawing a circle. Can our turtle make a circle? No. He can't. He can only turn. But we can have him turn 1 degree at a time. So, and they actually get down to an example in that in here, right here, where he actually turns, 1 degree at a time, so it looks like a good circle, but it's not really a circle. I think they show that on the next page. I'm just not going to type them all in for you. There it is. So we can actually do it. It's not a real circle, but it's close. Do you agree that's close? It is. It's close to a circle. So you can do it, and you can actually specify the radius. So I don't know. Everybody see how we did that? How we created modules? Now we can make them do different things. So at this point, you should know how to create a module. So your second program is going to need that, and it's also going to need you to use some loops, some for loops. That's about all. So far, that's what you should understand: creating modules, creating programs, naming variables, calling methods, that kind of stuff. Okay. All right. I think that's the end of it. Okay. Yeah. So far, we've talked about the primitive types. What's an example of a primitive type? Anybody? Silence goes over the field. Tuplets or numbers, just an integer, a primitive like an integer. Okay. Expressions, we can add stuff together. We can do different types of division. We can do regular division or integer division. We can name some objects. We just made a turtle called K. Okay. It says using modules and functions provided, we saw how to import certain things. So we can import turtle. Okay. And we can make our own. We may draw a square, draw a triangle, draw a spiral. Okay. All right. And why do we learn all this? Because that's what's in the book. And that's the end of chapter 1. Okay. I'm going to stop the recording at this point and cross my fingers.